Hey everybody, today we're going to be doing an installation of PiHole. PiHole is commonly referred to as a black hole for internet advertisements, and with good reason. PiHole software allows you to regain control over your network and see which domains are allowed in, and more importantly, which domains are not. The PiHole software runs on Linux, and it is commonly recommended to use a Raspberry Pi for it, and that's how we're going to be doing it in this installation. We're also going to be installing it on top of the Raspberry Pi OS. This is not required, but in my experience, it is the easiest way to go about it, especially for beginners. There are three versions of the Raspberry Pi OS that we can choose from here. We have Raspberry Pi OS with desktop and recommended software, Raspberry Pi OS with desktop, and Raspberry Pi OS Lite. Now, if the difference in name is not immediately obvious, then the file size should be. As we can see, the recommended software installation is nearly 3 gigabytes just for the download. The Raspberry Pi OS is a little over a gig, and the Raspberry Pi OS Lite is about half a gig. We're going to be going with the OS Lite for this installation, and that's primarily because we're using a Raspberry Pi Model 0W. Has limited processing power, so the smallest operating system with the least amount of programs running on top of it is beneficial to us in this case. However, if you have a more powerful Raspberry Pi, go ahead and download one of the ones with the desktop, and maybe even the one with the recommended software. It's Most of it is pretty good and fun to play around with. So go ahead and download whichever version of the operating system you decided to go with. Um, or you can alternatively choose a torrent of the operating system, which will go faster if you have the required software. But I already have it downloaded, so I don't have to wait. In the meantime, though, while you're waiting for the download, it might be useful to install an imaging software. We're going to be using Balena Etcher for this tutorial. However, I've heard good things about Rufus, but like I said, we're going to be using Balena Etcher. So if you haven't plugged in the SD card yet, now would be a good time to do that. If your SD card is pre-downloaded with some kind of operating system, you just need to format it in a way that your Windows operating system can understand, and Balena Etcher will take care of the rest. So we just need to select the image that we chose and flash. And now it's just a matter of waiting for Balena to do its thing. All right, we had a successful flash, as you can see. Sometimes this will not be successful. If that is the case, you will just need to reformat the card and reflash it. But in this case, we were successful. So when the card is flashed, it is automatically unmounted from the system. But for this installation, we are going to be doing it headlessly. So just unplug the card from your machine, plug it back in, and that should remount the card. And there we go. As you can see, we have access to the file system once again. It will automatically open up the only partition that we have access to, which is the boot partition, but it's the only partition that we need access to. So we are now in the boot directory of the card. In order to do the installation headlessly, we need to enable SSH to the machine before it even boots up. And in order to do that, we just need to create a file inside of this directory called SSH with no extension. Everything in Linux is a file. By creating this file, we are enabling SSH as the machine boots up for the first time. If you're plugging the Pi into Ethernet, this is the last step before booting up for the first time. However, we are going to be using Wi-Fi for the sake of demonstration. In order to connect to Wi-Fi headlessly, we need to create a file inside of this directory called wpa underscore supplicant.conf. We will then need to edit the contents of this file. I recommend using a program like Notepad++. This is what you're going to want inside of the file. I will include a link to this in the description. However, you're going to want to make some changes to this. Where it says wireless name, you're going to want to paste the name of your wireless network inside of the quotes. And the same goes for the password of your wireless network. Now, after you've plugged in your Raspberry Pi to power or Ethernet, if that's the way you want to go, then head on over to your router's admin console. This is what mine looks like. Yours will likely look different. What we're looking for here is the Raspberry Pi showing up on the network. As you can see, mine has shown up on the 2.4 gigahertz band of my wireless network. What we're aiming for is the IP. That's what I'm grabbing right now. Alternatively, we can also reach the Raspberry Pi by its default host name, which is, consequently, Raspberry Pi. You can see me pinging it here, and mine is online and responding to pings. However, using host name is very unreliable, so we're going to want to give this machine a static IP. Um, this is how it's done on my router. It is likely different on your router. However, a quick tutorial on how to set up static IP on your specific router is likely readily available somewhere on the internet. Once it's got its static IP, we are ready to SSH into it for the first time. I'm going to be using a program called PuTTY, which I will also link in the description. However, it is possible to do it from the Windows command prompt. Once again, this is not recommended. PuTTY is a much more reliable SSH protocol. However, if you are averse to downloading programs on your computer, it can be done once again from really any conventional shell. Again, it's recommended to use the static IP for the device. However, just to show that it can be done with hostname, I'm going to do that here. Now, the default login for the Pi is Pi as the username and Raspberry as the password. Huge surprise, I know. And we are in for the first time. Now, the very first two commands you should run on any fresh Linux install are first sudo apt update, and that updates your repositories, allows your Linux install to know what changes have been made since it was created. A lot of these changes are security changes, so this is very important to run. Now, on this machine, this is going to take a little bit, so we'll go ahead and skip to when this is done. Now we need to actually install those optimizations, so we're going to run sudo apt upgrade. It's going to ask you if you want to take up that extra disk space, and you're going to say yes. And once again, this is going to take quite a while on this single core machine, so we're going to go ahead and skip to when this installation is finished. All right, now that that's all finished and we've got a clean terminal, we're going to go ahead and upgrade our security. The first thing I'm going to do is change the password of the Pi user. The reason I'm doing this is because it is the most brute-forced login. When someone notices that you're running a Pi on your network, the very first thing they're going to try is the default login. However, a way more secure approach is to create a brand new user, give them an incredibly secure password, and then just remove the Pi user entirely. For the PiHole, the Pi user is not required. However, there are some programs running on the Pi that might require the Pi user. Now we're going to go ahead and add our new user to the sudo group so that they can run things as root. Now I'm going to go ahead here and open up a brand new PuTTY session and try to log in as my new user just to verify that not only do I know the credentials, but that the user works. And now we're in as our new user. Go ahead and close the old SSH session and work from this new one. Now we're going to just go ahead and remove the old Pi user entirely. Now we're going to want to navigate to our SSH server's config file and change a couple of things around to improve the security. Now the first thing you're going to want to do is change this default port up here. The default port for SSH is 22, and everyone knows that. But you can change the port for SSH on your particular machine. Take note of that port, however, because you're going to need to remember it when you SSH into the machine again. Pick really any port above 1,000. I will include a link of common ports just so you don't have any kind of connection conflict there. Now head on down to this permit root login, permit prohibit password, and if you have anything except that, change it to that. After that, go ahead and restart your SSH service. Next, we're going to want a firewall. For this one, we're going to be using UFW, which is known as the uncomplicated firewall. To install that, we need to run a sudo apt install UFW. Now after that, we're going to want to allow a couple of common ports, SSH and Apache access, namely. During this particular installation, I ran into an issue with UFW, which was pretty easily fixable by rolling back my version of IP tables. I will include the command I used to do that. However, during that bug, I had to restart the machine entirely, which I did not have to do for any other part of the install. So that was slightly inconvenient. However, if you don't run into that bug, this part is rather painless. So right here, I'm kind of double, triple checking that the SSH port that I assigned earlier is allowed, and then I'm just allowing the service entirely through the firewall. This is because I'm about to turn on the firewall for the first time, and as UFW will warn you, if you don't have the proper ports allowed, it will kick you out of the machine. But luckily, as Bash informing me that my garbage commands are not actually commands, tells me we still have SSH access to the machine despite the firewall being active. At long last, it is finally PiHole time. The PiHole installation command is really simple. It's one curl command. I will also include this in the description. And you know you've got it right when you see that wonderful raspberry black hole logo pop up. After a little bit, a couple GUIs are going to pop up telling you what the script is going to do, where you can donate to the people who made it, and that it needs a static IP. Next, we select where the Pi is actually getting its DNS information from, and then it gives you the option to either enable or disable the default block lists. I'm going to go ahead and leave them on. The script then asks you if you want to block ads over IPv4, IPv6, or both. Part informs you of possible IP conflict, however, if you set up a static IP earlier, this should be of no concern. It then asks you a couple of questions about the web interface, and if you want that to work, I would leave everything here default. Next up, we've got the privacy mode for the web interface. At the lowest level of privacy, you can see every DNS request made by every device on your network. At the highest level of privacy, you can see none of that. Go ahead and make those selections, and then let the script finish doing its job. At this point, you can kind of choose whatever you want for those questions, and the result is largely going to be the same uh, with the exception of course, disabling the admin console entirely. All right, once the script finishes installing successfully, you should see a message like this, which will tell you the address that you need to navigate to pull up the admin console of your installation, and it will also give you the randomized password that it sets up for your login. You can change the default password for the admin console to something we'll actually be able to remember from the SSH terminal by using PiHole -a-p. All right, now that that's done, we can go ahead and navigate to the admin console for the first time. If you didn't copy down that script from earlier, the address is just the IP of the Pi/admin. All right, now that we're in the admin console, we can verify that the Pi is working as a DNS server. So we're going to copy its IP address, open up our control panel, go to Network and Sharing Center, open up Change Adapter Settings. We're going to right-click our current network adapter, go to Properties, find Internet Protocol version 4, right-click that, find Properties, and then we're going to change our DNS server. And again, the DNS server that we're going to set this to is just the IP address of the Pi, which at this point should be a static IP. Now, if your Raspberry Pi is working as a DNS server, then if you navigate back to the admin console, you should see one more client pop up, and that should be the client of whatever Windows machine you just put on it. To change the DNS server manually for each device is a little tedious, however, so what we would like to do is set our router to use the Pi as its default DNS server. Again, this is what mine looks like. Yours will most definitely look different. You might even find yourself in the situation where you cannot change your default DNS server, such as if you rent a router from your ISP. In that case, you will have to change each of the devices manually, which is a pain.